because that does give us a little bit of a difference. So a survey found that the average hotel room should be rate in New Orleans is $88.42, and the average room rate in Phoenix is $80.61. Assume the data are obtained from 2 samples of 50 hotels each, and the standard deviation of the population is 5.62 and 4.38, respectively. Find the 95% confidence interval for the difference between the means. All right, so we're going to make sample 1 and sample 2, because we got 2 sets of information. So we've got 88.42. What is that? The mean. So that's one mean. X bar 1 is 88.42. What about 80.61? It's the mean for sample 2. So 80.61. Then it says, assume that it was obtained from 2 samples of size 50. So that means the N1 is 50, and your N2 is also 50. In this case, they have the same sample size. And then we want to look at the standard deviations, and they said that they were respectively. So that means sigma 1 is 5.62. Sigma 2 is 4.83. Exactly. Which is why it's not super realistic, but we're going to get into a distribution in the future that we do not know with the population information. Yes? Oh, it's supposed to be 2. Thank you. All right. Now let's try and find our pieces. So we want to be 95% confident, so our C level is 0.95, which means that alpha is 1 minus 0.95, which is 0.05. So alpha divided by 2 is 0.025. And what was the z-score that went along with 0.025? 1.96. And you can find it again like we did in example 1, same method. If we know it, we can go ahead and just use it. So the first thing I want to find is my margin of error. So 1.96 times sigma 1 squared. So we got to take 5.62 and square it, and then divide by its sample size, plus sigma 2 squared, which is 4.83, square it and divide by its sample size. And then you want the square root of that whole thing. So let's see what we're going to get for that. I tend to put it all kind of in at one whack, but you can do whatever you want. It takes a lot of parentheses if you're going to do it all at once. And you can do it a piece at a time and kind of add it together. Doesn't make too much of a difference. All right. So then what I want to do is take that number. I got 1.0, go to 1.05. You can round to slightly different places if you want. And then I'm going to say, all right, I've got my margin of error. Are there questions on the margin of error before I continue too much? Oh, that's not my margin of error. That's just the square root. I still need to do 1.96 times that 1.05. And let's see what that gives us. $2.058. Does everyone agree? All right, just for simplicity's sake, I'm going to find the point estimate before I kind of put the interval together. So I need to do x bar 1 minus x bar 2. So 88.42 minus 80.67. What is that going to give me? What? Oh, just keep writing all the wrong numbers. 7.81. All right. Now I've got my pieces. I'm going to put them together to build that interval. So we've got 7.81 minus 2.058. And then 7.81 plus 2.058. And again, I would do each piece individually when I'm adding them together. Let's see what that gives us. What does that give me? 5 point something. $7.81 minus 2.058. 5.752. And if we add it, $9.868. Does everyone agree? Yes. Wait, what? What is this interval supposed to contain? The difference in the means of the populations for those two cities with their hotel room rates, right? So the difference in price. I'm still going to start my sentence the same and say that we are 95% confident that this time we're confident that the difference in the room rates, the mean difference, in room rates between the two cities is between, and I'm going to round to 2 decimals because this is money, so 5.75 and 9.87 dollars. I already put it. My 9? This one? All right, questions on that? So the other thing that we can tell from this interval is not just that the mean difference is in between there, we can also be 95% confident that the average room rate in New Orleans is higher than that in Phoenix. Why? Why can I be confident of that? Well, the survey showed it, but I also built an interval that's supposed to contain 95% of data for any samples of size 50, and they're all positive numbers. The difference is positive. And we did the New Orleans mean minus the Phoenix mean and got these positive numbers. So that means that we can also be confident that New Orleans on average is higher than the room rate in Phoenix, which we probably would expect anyhow, right? People tend to want to go to New Orleans more than they want to go to Phoenix. So we would think that the difference would probably be positive if you have New Orleans first and you're subtracting that one first. Does that make sense? So we can get more information from this besides just that, oh, there are differences in between here. We can also tell whether it was, which one was higher and which one was lower, things like that. So that's kind of useful information as well. Well, that is all super fun to do. And you can use the formulas. They work just the same. You're going to get them. But I want to go over the calculator. So if we could do the one sample by going to stats and then test, we can also do this one. We're just going to go to stats, test, and to sample z-test, or z-int, sorry, z-int. We're doing intervals. So let's go find that. We go to our stats. I need to clear everything because I got too much going on. And you go over to the testing area. Now we have to go past this one sample z interval. And you got to find the one that says to samp z int, because otherwise it doesn't give you the correct blanks to plug information in. Again, we don't have a list of numbers, so we don't have data. We have statistics. And then I want you to fill in each piece. So the first one, standard deviation, was 5.62. The second one was 4.83. The X bar for the first one was 88.42. And the sample size that went along with it was 50. The second mean was 80.61. And its sample size was 50. And we want to be 95% confident, so 0.95 for the confidence level. And then we want to calculate. Our intervals are pretty similar, especially when we round for our money. They're a little bit different due to rounding, but they're pretty much similar. So 5.756 and 9.864. So you would get that interval, and then you would come back and give me this sentence.